is Amanda Bull-Chafin. I work at the Lane Community Technology Center in Hamilton, Ohio. Welcome to part 1 of our spring series. In this series, we'll be creating our very own custom light-up acrylic sign completely from scratch. This project is really fun. I hope you guys like it. I had the idea just because I saw these signs on Etsy. My mom really likes Etsy, and it was around Mother's Day. And I was like, I could probably make something like this for her. And I happened to see what I had laying around, and I had a Gemma and I had a Neopixel. And I ended up making a really cute sign that she liked a lot. So now what I'm doing in this video is I'm sharing with all of you the in-depth, step-by-step process of how to make that. Now, it's a little too long for one video, so I'm gonna break it up into 3, okay? So the first one is the electronics. The second one, we're just doing the 3D design part, so the base that hides the electronics and supports the sign. And then the last one, we're gonna do the sign itself, and that's the part that everyone's gonna see. Does that make sense? So let's get into it. I promise it won't be as daunting as it seems, and it's gonna be really fun. In this video, I'll show you how to wire and program the lights. In our second video, I'll walk you through the process of designing a 3D printed base to hold your electronics and support your sign. Finally, in the last video, I'll teach you how to design, cut, and etch the laser cut acrylic sign. That means that now is a really good time to subscribe to our channel to make sure that you don't miss the upcoming parts of the project. Start by gathering your supplies. For this project, you'll need a soldering iron, lead solder, tip tinner, which is optional, a damp sponge, helping hands, wires, wire trimmers, wire cutters, which are optional, an Arduino Gemma microcontroller, a 12 LED Neopixel ring, a USB cord, a computer, a web browser, and Arduino software. Today, we'll be using an Arduino Gemma microcontroller to control a 12 LED Neopixel ring. If this project looks familiar to you, that's because I did a brief overview of this project last year. This video series breaks each part of that project down into its constituent parts. This might also look familiar if you watched our previous video about how to light up a 3D printed snowman base. We used the same components, except this time we're only using one Neopixel. It's a good reminder that these skills and components are transferable to different projects. The wiring for this project is actually pretty simple. So you're actually just taking ground to ground, power to power, and then D1 to in. You can use any color wire that you want, but I usually try to make my ground wire black and my power wire red, with my data wire being any other color. That way I can tell at a glance which wire does what. If you've never soldered before, don't be overwhelmed. Remember, it doesn't have to look perfect, it just has to work. All you do is use wire strippers to strip the insulation from the ends of your wires. Then press the tip of the soldering iron against the pad and push about 1 millimeter of lead solder against that point. It should melt into a neat little pool of metal. When you take away the heat, the metal solidifies in place, fusing the wire to the board. Make sure to wipe the tip of the soldering iron on a damp sponge every time you finish soldering. If your tip is dirty or dull, it may help to have some tip tinner handy to keep your tip usable and shiny. A word of advice, it helps to tin your leads, which just means coating the ends of your wires in a little bit of solder before you solder them to the board. Now, once you've done the wiring, it's time to select the colors and the animations that you want for your light show. I like to use the LED strip effects generator. You can find it on GitHub. I will link to it in the description. I did not make this. It's by Jose Maria and Adriano. What I really like about it is that when you change all the parameters, you can actually see a real-time animation of what it's going to look like. So it makes it a lot easier to know exactly what your code's going to do before you upload it to the Gemma. The first thing you do is add a strip. Then click it and change the LED quantity to 12 and the pin to 1. Now in the loop section, add an effect. Customize the animations and then tweak the colors. I really like this generator because you can see your changes in real time. When you have the effect you want, click the Generate button. And now copy the code. It's that easy. If you're enjoying this video and you want more like it, don't forget to like and subscribe, or even leave a comment. I try to answer all questions in a timely manner. You can also give us a shout out on Facebook. It helps us spread the word about all the cool resources and services we offer. Now that you have the code, you need a way to upload it to the Gemma. So how do we do that? Well, that's where Arduino's free software comes in. It's available at Arduino's website, link in the description. In Arduino software, we're first going to open a new sketch. Then we need to set up our preferences. So to do that, go ahead and click File and then Preferences to open the Preferences menu. Now you're going to click the Display Line Numbers checkbox. If you happen to get an error in coding, a lot of times it'll tell you which line of code it's on. That's why it's helpful to have the line numbers listed. Under the Additional Boards Manager URLs, you're going to want to add the following URL: https://adafruit.github.io/Arduino-board-index/package_adafruit_index.json, and then click OK. It's important that you add the URL exactly as it's written. Otherwise, you may get an error when you try to upload your code. Don't worry, I'll include this link in the description below. Before we can tell our software which board we're using, we need to install our Gemma through the Boards Manager. Click Tools, Board, and Boards Manager to open the Boards Manager menu. In the search bar at the top of the menu, type the word Gemma. Locate the entry called Adafruit AVR Boards by Adafruit and click Install. Now that we've installed the Gemma, we can tell our software to select the correct board. Click Tools and then Board. You'll notice a lot more boards appear on the menu now that we installed the Adafruit AVR boards. Click Our Board to select it. You're looking for Adafruit Gemma ATtiny 85 8 MHz. The programmer is what allows you to actually burn sketches to the Arduino board. We need to point our software toward the right setting. So to do that, we're going to click Tools and then Programmer, and we're going to select the correct programmer. In this case, the one that you want is USB Tiny ISP. A library is like coding shorthand. Instead of typing lines and lines of meticulous code by hand, we can tell our code to look in a specific code library and just do what that says. All we need to do to use a library is install it. So to do that, go ahead and click Tools and then Manage Libraries to open the Library Manager. Type Adafruit Neopixel into the search bar at the top of the Library Manager. Locate the Adafruit Neopixel by Adafruit library and click Install. Click Close to close the Library Manager. Okay, so remember that code that you copied? Now we're going to use it. So if you've copied anything between then and now, you need to go back and copy that code again so it's on your clipboard. Plug in the Gemma now, connecting it to your computer with a USB cable. Now click anywhere in your sketch and press Ctrl and A or Command and A if you're using a Mac. This selects everything in the sketch. Now press Ctrl and V as in Victor or Command V on a Mac to paste your generated code, completely replacing the existing code in the sketch. Before we upload our code to the Gemma, we need to verify that we've configured everything correctly. With the Gemma plugged in and the code complete, click the Verify button at the top left corner. It looks kind of like a check mark. If you've done everything correctly, the black strip along the bottom will display a report. If you've made an error, the black strip along the bottom will display an error message. If no errors are present, then it's time to upload your code. With the Gemma plugged in and the code complete, press the small button on the back of your Gemma. A red light should blink. The blinking light means that the Gemma is in bootloading mode. Pro tip, the Gemma can only accept new code when the red light is blinking. Click the Upload button at the top left corner. It looks like an arrow, and it's right next to the check mark. If you've done everything correctly, the Neopixel will flash and then begin your animation. So great job, you did it. Next time, remember what we're going to be doing is we're going to be designing the casing for our electronics, and it's also going to be the base for our sign. And then after that, what we're going to do is we're going to design the actual acrylic sign itself. So you might want to subscribe so you don't miss those videos. Next time, we'll be measuring our components with calipers and then using Tinkercad to design a custom base that houses our electronics. For now, pat yourself on the back for a job well done. If you're located near Hamilton, Ohio, and you'd like to learn more about laser cutting, 3D printing, or programming microcontrollers, give us a call at 513-785-2727 or email us at techcenter@lanepl.org. For hours and location information, check out our website at lanepl.org.